Hey everybody, welcome. Welcome once again to Astronomy Daily Live. So you might be hearing some sound in the background. I've just, every single Sunday, Music from the Hearts of Space does a free episode, and so you just have to sign up, and uh, every single week I get the latest episode, or sometimes it's a repeat. This week's episode, which was free today, is a repeat, and a relatively recent repeat. I mean, in the past 5 years or so. I think it was a repeat of episode 901, and it was definitely not exactly uh, uh, even in the top half of what I've heard. So it was definitely in the bottom half. Pretty boring. But I record these anyway, because you never know, right? You never know. I'll wake up in the middle of the night with some kind of sound, right? It's like, oh, it's like a piece, some kind of piece of a song or something, and I'll have to find it, right? And so you never know where those kinds of things happen. So today's episode, as far as I'm concerned, now you should go listen to it, right? Because I'm just one pretty picky um, uh, space music nerd. So if it isn't sort of in this realm, which you're hearing now, if it isn't in this realm, then I'm not incredibly impressed. Anyway, this particular episode I recorded a few weeks ago, and it was episode 1201. So that's what I am playing in the background here. And I don't know if it's any kind of copyright problem or anything. If it is, then I'm sure that somebody will let me know. And yeah, that's that. But I've done this a few times before and never had any kind of problem whatsoever. So, but we'll see. We'll see. It's extremely easy to have on. It's extremely easy to have off. So, whatever. So, all right. Well, cool. So it's been. Before I get too far into the live stream, gotta say that I'm gonna look at the chat, see all the shenanigans going on at the chat. Yes, all the usual shenanigans. But also, howdy to Bobby on the panel. Hey.
Oh, what a day, and what a great day to end with some good Astronomy Daily Live.
So you had one of those days? Is that what I'm sort of hearing?
No, I just suffer from cake fine crap.
Ah, I gotcha. Well, you got to have the bad days to really, really appreciate the good days, right? If every day was exactly the same, it'd get a little bit boring after a while, right? I mean, it might take a while to get bored, but eventually you just sort of get tired of it, right? It's like, so it's nice that there's a little bit of variety, that there's a little bit of probability, right?
And you might want to run a malfunction check because Tim didn't get the panel link.
Let me see who I sent it to. I can I can check that really quickly here. Thank you for letting me know. You know, let me know if things don't happen the way that you're sort of expecting them to. Let me know. You know, don't hesitate on that. Yeah, dude, I missed you. So here's a special one coming right to Tim. Man, my automatic systems are not very well established. All right, there you go, Tim. I usually have that. I mean, you know, by now, right? Since I've been doing this practically every day for I don't know how long, over a year and a couple months, year and a few months. I don't know. But you know, you would think that after a while, I would get into the habit of just doing exactly the same thing every time, and that's just not true. That you know, that definitely proves that I am quite the human, right? Just messing stuff up. Any chance I can get, I'm gonna mess it up. So that's just like any typical human. So, all right. Well, cheers. I've got the hydrogen hydroxide here.
And I got my faucet water.
Excellent. Yeah, this stuff is pretty amazing. You will never hear me ever say anything bad about this. The worst thing that I'm going to say about this stuff, and you know, somebody's got to probably has to do something about this because it's sort of a gripe that I have about I guess one of the characteristics of this particular set of molecules. Ah, there's Tim. Hey. I guess one of the characteristics of I'm hearing good echo. Molecules. Ah, there's Tim. Hey.
Hello, everybody.
Hey there, Tim.
Yeah, I'm going to put my headphones on. Just one moment.
Good. I think that's a good idea. I see that there's Sue in the background. So hey there, Sue. Nice to see you. It's really amazing that we can do this kind of thing. Tim and I are separated by a third of a planet at least, and wow, you know.
You're just separated by the Atlantic Ocean.
That's we're separated by I think 7 hours right now. I think 7 hours or 6 hours. Maybe it's going to be 8 hours. I think it's going to be 8 hours. But I think I don't think Europe has jumped forward yet. But anyway,
no, not yet.
Yeah, but yeah, no, I think it's just absolutely fantastic and great that you know we can get together here on sort of this virtual porch and you know just sort of hang out and you know consume things
with my virtual beer.
and yeah, you know, just have a ball. Everything so Tim, everything good over there? Everything going well?
Yeah, not too bad, thank you. Yeah.
Good. Excellent.
Spent a full day trying to catch up on subscribers, YouTube subscribers.
Oh wow! Yeah,
I'm still about 60 behind.
Yeah, that's a job, you know.
Yeah, my channel's just gone bonkers lately.
Good.
I think
Excellent.
from in 2 weeks, I've gone from something like 69 subscribers to 270. So
Wow.
it's building quickly.
Yeah, pretty awesome. Very, very awesome. Very cool. Anyway, yeah, my only gripe that I have about this particular molecule, one of the characteristics of this is that it's like really, really wet. And I'm just wondering if somebody can do something about that, right? Because, you know, it's kind of annoying. So I don't know if that's really, you know, the only thing that I'll really complain about this at all. Otherwise, it is the most amazing molecule, I think, in the entire universe. It's just incredible. So it's great. Well, cheers.
You can't have it dry. You can't have it dry, that's for sure.
Well, that must be exactly the same liquid that rains around your president. It's very, very wet.
it's just wet. It's just wet, and I think somebody needs to do something about that, but I can't figure it out yet. So, yeah, somebody smarter than I is going to have to get in here and solve this wet problem. So
separate the molecules and consume them separately.
Well, yeah, I don't know. It's just a weird thing. Anyway, so it has been pretty clear here most of today. Coming into this afternoon, we actually had what I would call a monsoonal buildup, where the clouds just sort of build up over the mountaintops.
I'd like to welcome Chuck in the chat.
Hey there, Chuck.
I forgot to put my other monitor on.
Where the clouds, form over the mountains, and then it rains, and the clouds vanish. Well, that is exactly what happened today. That usually happens during the monsoons. So it's a little strange to see that kind of buildup here. It's not entirely. I think I've seen that a couple times before, but it's relatively rare. But now I think the clouds are beginning to dissipate out there, and there's a variable star, an eclipsing binary star, that I've actually observed. It's XZ Canis Minoris. It's right almost next to Procyon, right next door to Procyon. So it's up high in the sky. The eclipse starts. I've got the here. I'll now that I've sort of pushed you into this, I'll show you what I've got here. We can sort of go through this a little bit here too. Okay, so I'm going to share my screen. Share the screen and do that and do that. And go over here. So I've gone over to the AAVSO variable star index, as they call it, and I've done a search already for XZ Canis Minoris. So Canis Minor, of course, is the small dog, which is right next to the large dog, Canis Major, which is just east of Orion, sort of southeast of Orion. Anyway, so yeah, well, here are the celestial coordinates. Here, yeah, just sort of some basic information. So it's an eclipsing binary star. So this is actually two stars an A component and a B component, and they're either of different spectral type, or uh, uh, yeah, I think it's mainly spectral type is different. So one is going to be slightly brighter than the other one, and so they are going around one another, right? And so you can kind of imagine the B component orbiting the A component, right? And they're the configuration of the orbit is such that from our line of sight, from our point of view, the B component actually passes in front of the A component. And what that does as an effect is you see this star go from relatively bright to relatively faint, and then back up to relatively bright in a matter of a few hours sometimes. It sort of varies a little bit. There are different types of these kinds of eclipsing binaries, depending on, I think, like how much of an eclipse there actually is, probably all kinds of other things too. But I observed this guy for the first time, I don't know, maybe a month ago or so, maybe a little bit more, maybe back in December, maybe. Don't remember. But it's got a pretty good magnitude range, right? 9.7 to 10.4, so about 0.7 magnitudes, which is about a factor of 2 difference in brightness between its faintest and its brightest. So that's pretty good. So the B component is orbiting the A component every 0.57 days. So yeah, that's 14 hours, right? So every 14 hours, this one star is just whipping around this other one. And as I said, from our line of sight, that B component passes right in front of the A component and dims the whole system. But it's doing this really, really fast, right? Really, really fast. And so what you can do is you can look and see when the predicted eclipses are going to happen. And I did that in this case, and I came up with this list here. And as you can see, it's right now it's 2:19 UTC on the 18th of March 2019. So as you can see, in just a few hours, one of these eclipses is going to start. And then here is the midpoint when the star is going to look its faintest, and then here is the predicted end when the star is sort of back to where it normally is. So yeah, that's about a 3-hour event, right? 3 hours out of a 13-hour period. So 13 hours later, as you can see, it's doing it again. And then 13 hours after that, 13, right? So, but, I'm looking at this and it's like, well, I have to sort of think of, well, I definitely have to make sure that I'd be able to observe the entire thing. And if you sort of look through this list, right, this one I could probably do also, but it's, in the morning, at least where I am. Yeah, that would be a little bit more difficult one to do. This one here
Hey,
is.
Ron from Radio.
Hey there, Ron.
Hello.
Hello, Ronald.
Hey, cool.
Hold on.
Glad you could join us.
Just real quick. In between music.
In between music, man, he's doing 500,000 things at the same time. I know it.
That's me.
How are you doing, Ronald? Okay?
I'm doing okay. Yeah, I had a laptop that got fried for some reason. I got the Windows 10 update,
Ouch.
and for some reason it really didn't like it,
Wow.
and
So-
so I ended up having to restart my desktop again, and it's doing okay.
Wow. Okay.
At
Wow.
least
That's.
I had a backup though, but I contacted the computer people that I bought the laptop from. It was supposed to be brand new, as they said, and so I don't know what the update was or why they didn't want to accept the update. You know, on the laptop, why it didn't want to work right. But I've heard of other things with that Windows 10 update, so I know it's not anything I'm doing. It's something that they have with the program.
Yeah.
And-
Wow.
And I contacted them and I said I either want a replacement, a refund, or repair.
Right.
So one of those three things. And if they can't do that, then I will work on shutting them down when I get
Yeah.
done.
Yeah.
So,
Well, yeah. That's just sort of like a warning to us all. It's like either get Windows to install or we're gonna fry your computer.
yeah. Yeah. And I actually have three other laptops that I've had that had the updates that they all quit working.
Gee.
Okay.
Yeah.
Now I've heard of some ghost stories about things like Microsoft doing that, but there's no actual proof to it. So you can't really claim that on any level. For any proof. But
Yeah,
I mean,
those are the kinds of things that you definitely you have to be checking that, and I would think that kind of thing would have been found, right?
Yeah.
Because they don't do a release until they have tested this thing for months,
right.
What's that called? Gilles talks about it all the time.
You mean the testers, the insiders?
The insiders, yes.
Yeah.
Yeah.
Okay.
Yeah. The Windows insiders are basically free beta testers, right?
Mhm.
For these updates, and so the update that we're getting like now, right? That started its life probably 3 or 4 months ago, if not more, and it's gone through a lot of beta testing. So for that kind of problem to slip through, wow, that's.
Well, I don't know why. I don't know why the computers. I have three laptops that just quit working after I got the Windows 10 update, and then now I have this brand new one that I just got that was supposed to be ready to go with this update stuff,
right.
And then it didn't want to accept it. I have an error that came up and said started IPv4. And then it timed out. Then it tried to start IPv6, which is a network thing,
Mm-hmm.
And I don't know what all that is a problem with, but it should be working. I shouldn't have to be worried about it, to be honest with you.
You might want to check your BIOS and see where you're booting from, because that sounds to me like it's trying to do a network boot. And
no, I have it directly wired to the router, and it's only one network that's on.
Well, no, but what I'm saying is that is that you got to look at your boot sequence and make sure that it is booting from like the hard drive, right, and not from a network or
it should not be. Yeah, it should be just booting right to the C drive, which is the main drive.
Yes.
So I don't know why it would change unless somebody got in there and messed up with it, hacked into it or something.
Yeah. Well, as I said, I would look at the boot sequence.
All right, I will do that later. I'm not going to worry about that now.
Yeah.
I was ready to get my torch, my butane torch after.
And another thing, Ron, check and see if you're doing from regular BIOS or from the UEFI.
It's probably UEFI.
Probably, yeah.
Okay, what now?
Yeah, because like the newer Windows systems that come with UEFI.
Oh yeah.
UEFI, yeah.
Oh yeah, probably.
When you turn on, it's going straight to system.
Right.
Yeah.
Yeah.
All right. Well, I gotta get going. I just wanted to come over here and say hello, and I got your message. Awesome. And I apologize. I have to. Amanda's doing her comedy show on my station, so I have to get over there and watch that.
When is that?
That is like at 10:30.
10:30 your time.
Yeah. So like right now, it's gonna be starting.
Oh, okay, yeah, in just a couple minutes.
Cool, Rodney. Yeah. I'll see if I can pop in a little bit later on.
Wanted. Yeah. All right. Thanks, guys. Just want to say hello. All right.
Okay, yep.
Take care, buddy.
Bye now.
Bye for now.
Later on.
That was a dive bomb from ERT Radio.
Smashing bloke he is.
Yeah. Anyway, so there are other opportunities. 229. That's right when my astronomical twilight basically starts. So that's a very convenient one too, right? But that's going to happen in 5 days, and I don't know if it's going to be clear or not. I don't even know if I'd be interested in doing it, right? But I've got this one tonight. So I'm sort of thinking that I might do that one. The moon's going to be right next door, but with this variable star stuff, what you do is you compare it to another star in the same field of view that isn't changing brightness. You can call it a standard star, and so you just measure the difference between the magnitudes. And you see, that one of them, substantially dims. So that has nothing to do really with the brightness of the sky. So the moon can be right there, and no problem at all. As long as I can see the stars, which I can. This is relatively bright. 10th magnitude. So that is significantly bright. So yeah, I'll have to think about that. For me, that's starting at the eclipse starts at about 10 p.m. and goes to about 1 a.m. And I'd want a little bit of data beforehand, a little bit of data afterwards. So yeah, I'm talking about like a 4-hour commitment on that. So yeah, I'll have to think about that. Yeah, we'll see. But pretty interesting system. I was over on Simbad, sort of reminding myself about if there was anything particularly interesting about this binary system, and I don't remember anything really. Maybe it's what's called a contact binary, where the two stars are actually sharing a sort of a mutual atmosphere. Here they're calling it a near contact binary. So yeah, pretty interesting though, and you know, it's also because its period is so quick. There are usually, you know, multiple opportunities to observe this. We can actually go over to the AAVSO light curves and see what they're showing on here too. So let's see, it's going to be zoomed in or not. So the latest observation was February 24th. So that would be this over here. There have been a couple other observations. Let's see. We can zoom in here on maybe the
That
latest.
link at the top there, adopt this star, is that where you pay to have it named?
Yeah, I guess so.
Yeah, my wife did that for me quite a few years ago. She bought one for me, and I can't even remember where the hell it is.
Well, and you know, I think it's really, you know, that kind of thing is a really great sentiment, but it's
But it
like
doesn't make a blind bit of difference.
whatsoever at all. But
exactly.
I think it's cool though. You know, I mean, it's very romantic. So yeah, that's nice.
It might be until you hear the name that she called it. Terracotta Tim.
That's great. Anyway, so this is the latest observation of this eclipsing binary star, and as you can see, it's going. It looks like it's basically peaked out here. So what, about 10.05 or something like that, and then it just dipped down all the way, fainter than 10.7 or so. I'm sort of looking too at the symmetry of the curve, and I guess it looks pretty symmetrical. This side maybe is coming down a little bit faster than this one's going up. You see that? How it's kind of hard to tell, but it looks like that this side dives a little steeper.
Yeah, it's not a mirror image.
Yeah, it definitely isn't. So, you know, those little subtle things like that can tell you things about the geometry of the orbit. Maybe even, you know, the relative size of these things. Yeah, you know, the extent, you know, how long this eclipse actually lasts can give you a good idea of like the atmospheres of these stars, you know, how thick they are. Yeah, it's just amazing. So let's see, this goes from 3928 to 3942. So those are in Julian days. So let's see, 0.42 minus 0.28. It's 0.14 days, which is right. So from here, right, 3928 to 3942 is 3 hours and 21 minutes from there to there. So pretty interesting, pretty good data. You know, yeah, this person really has his photometric game turned way up. So really nice. You know, good coverage and not a lot of wiggle, right? Not a lot of noise here. So your precision is probably really good. So pretty nice. Pretty nice. So yeah, I guess I have to decide if I'm going to do that or not, because I created a light curve with the data that I have, and I don't know. It's not this nice and smooth. So, and what I've got is at least at the moment, substantially noisier too, right? It's not. I mean,
It'll depend where you're observing from, won't it?
No, it really has to do with the equipment you have, and
Right.
and how carefully you're able to process the data. So yeah, this is just um, um, if I decide to sort of get into this a lot more, then I'll definitely want to work on improving things. I think what I've got now is adequate, but it definitely isn't this good. So yeah, it's just something to aim for, perhaps. But pretty nice obvious dip here. So all right. Well, let's see. Where shall we go? Let's do one more. Let's do one more quick look at Leo. See if there's any more trouble that we can get into over there.
I'm a Leo. It's definitely trouble.
Yeah. Because we definitely got a nice thing with the cosmic horseshoe. That was nice. 2903. I think we looked at 2903.
Mm-hmm.
Home to some of the largest structures in the observable universe. Large quasar groups. Very cool. Of course, we've got the Leonids, which if you haven't seen them yet, you definitely should. It's worth seeing. History and mythology.
I've forgotten what time of year is the Leonids.
November.
November, right. I think I saw those. Sorry.
Yeah, there's sort of a peak every 33 years, and the last one happened around 1999 or 2000.
Mm-hmm.
So expect another peak in another 12 years, 13 years or so.
I'll be 25 by then.
Yeah. Yeah. So I saw the one that happened. I'm pretty sure it was in the year 2000. Could have been in 99, but I think it was in November of 2000, and that was an amazing sight. That was a true meteor shower. I mean, there were meteors, several meteors per second.
That's a lot.
So it was crazy. Yeah, that was an amazing sight. I'm glad I was able to see it. Don't have any kind of record of it though, except my memory, and that's it. But it was pretty epic. Okay. Well, it looks like we're pretty much done with Leo. And it's pretty good timing, because Leo is up at night now, so we can definitely easily go out and see it. If you're in the north, if you're over in the south, Leo, you would definitely be able to see if you weren't too far south. But yeah, if you get way too far south, you're not going to see it at all, for sure. Okay. Well, all right. Well, I think I'm going to call Leo done. I think we have just squeezed about as much as we can possibly squeeze out of that constellation. Good constellation, nice big one, lots of good stuff. And I mean, we've barely scratched the surface on this guy. So, and it's been, you know, weeks. so yeah, I guess it's about time to move on with that guy. So I'm sort of wondering, why don't we let's do an NGC of the day. We haven't done one of those in quite a while. So I've got Nightbot programmed to spit out a random number between 1 and I think it's 7,840. There are that many NGC objects, new general catalog objects. Most of them are galaxies, but you've got everything else there too, right? You've got the globular clusters, you've got the open clusters, you have the diffuse nebulae, you have the planetary nebulae. So you're pretty covered. And mixed in with those non-stellar objects, right, are also stars that they just, you know, due to faulty observations or whatever, you've decided that some stars were actually NGC objects. So yeah, there's, you know, those kinds of mistakes are made, and you just sort of carry on. So Nightbot can choose this for us. Either that, or I can go over to random.org and do the same thing. But let's see if Nightbot is awake. I don't think that anybody has tapped Nightbot on the shoulder yet, so I'll go ahead and do that. And Nightbot can hopefully choose our NGC object of the day. There it is. Yay. So over in the chat, you can see that, I think. NGC 3660. Okay. So let's get over here. Now 3660, you know, the NGC catalog is essentially arranged according to right ascension, right? And right ascension goes from 0 hours all the way around, you know, to 2359. Yeah. And then it wraps, you know, back around, you know, to 0. So the fact that this is what, 3660. So 3660 divided by 7840 is roughly 0.46, right? And over a 24-hour clock, that would put it at about 11 hours. Maybe just a little bit over 11 hours in right ascension. So let's see how close that actually is to what the NGC number sort of predicts it should be. So NGC 3660, right? Is that what Nightbot did? 3660, yeah. Here we go. So it's a galaxy. Surprise, surprise. And a Seifert is a special kind of galaxy. It's a a particular kind of active galaxy, which, yeah, let's, we could dive into that a little bit, and because I don't remember all these terms all the time, but let's take a quick look at the basic info here. Wow, so yeah, look at the right ascension is really close to what the NGC number predicts it to actually be, so that's not too bad.
You were very close there in your mental working out. 11 hours, 4 minutes.
Yeah.
Yeah.
Well, and Tim, this is absolutely no mental exercise at all. I've got the calculator right there.
That's what I just did. I thought, bloody hell, that's accurate.
No way.
I thought you did that in your head.
Not a chance. Not a chance. You give me way too much credit. Let's see. So pretty small, right? Less than 1 arc minute in size on each side. So that's pretty tiny. It sort of implies that it might be kind of far away. I guess they're calling this a barred spiral of type B. And if we look at the picture here, I guess you can sort of call that a bar, right? There's a bar, and then it's an SB because these arms aren't incredibly tight, but they're not incredibly loose. They're just sort of right in the middle. So yeah, and I guess you can call that a bar. Let's see if okay, yeah, that's a better view. Let's open this up. I switched to the Sloan Digital Sky Survey, this one, and you can definitely now see that there's a bar there, as they call it, and then the arms are sort of spiraling off of that. All right, so let's go back. Let's go back here. Pretty darn faint, right? You're definitely not gonna see this in your 8-inch scope, or really even your 16-inch scope, right? You need something pretty substantial to see that faint. You got a V magnitude here of 14.45, so that's already getting pretty darn faint. Definitely, though, if you're doing any kind of photographic work with either like a CMOS camera or a CCD camera, yeah, you could definitely do some really nice things, probably starting at about maybe like a 10-inch or 12-inch scope, with some relatively decently long exposures. You could probably get some pretty nice shots, and I wouldn't be surprised. Let's find out if Cloudy Nights has any good shots here. I'll just do a search for 3660 3660. It's looking at articles. I don't know why. Articles and reviews, members, help files. I guess.
Photo gallery?
Yeah, there's. Yeah. Yes. Oh, maybe is this? Oh, yeah. No, not there. Not. Yeah, not that one either. And yeah, I don't think that. Wow. Okay, so there aren't any. Doesn't look like there's any shots. Shots here at all. Let's look in the forums. If it's going to be anywhere, it's going to be there. Big Dob searches for 11 supernovae. Sort of implies, yeah. Oh yeah. Oh, UGC 3660. That's a different catalog. It's a good try. Yeah.
Laura's gotta be like super busy lately.
The what does have to be busy?
Ottawa.
Oh
Attila
yeah.
Hinter.
Yeah. I think so. Well, hopefully things are going well for her. So yeah, wow. So no pictures of that guy, even on cloudy nights. That's
You try NGC 3660 or that won't work.
Well, I just put in 3660 because that's going to find it if it's there, I would think. So I can certainly try 3660 like that.
Yeah, attack then.
No heart attacks allowed.
Oh.
At least not on my live stream.
I nearly had one.
So why is NGC 3660 coming up in this search? Ah, there we go. That's why. Okay, so I guess there was a supernova event. Pretty bright back in 2017. Oh wow! So yeah. Oh yeah, that might be the magnitude of the galaxy itself. So well, that's kind of cool. I wonder if there's any papers about that. So here's all of its other names. Always a nice full list. Can't have one name when you can have 20.
That's for sure.
So wow, so lots of papers.
Definitely been studying.
It's been studied
Lots of pepper.
Pretty hard.
A lot of references.
Lots and lots of pepper.
Yeah. Not saying anything about the supernova. I would have expected to see something on or around 2017 about that, but I don't see anything in particular. Let's definitely go and find out a little bit more about Seyfert galaxies. As I said, it's a particular kind of active galaxy. And an active galaxy is just a galaxy that seems to be doing something, right? You look at for instance, the brightness over time, and it varies in some weird way that nobody's understanding yet. But they've categorized them in different ways, and the Seyferts are just one of those. I don't know how many active galactic nuclei types there actually are. Seyfert is definitely one of them. trying to think of the other ones. There are. Well, but those aren't galaxies. I was thinking. What came to mind was BL Lacerta objects, but those are. Oh, I don't know if those are on the galactic scale or on the star scale. I guess those are active galactic nuclei as well. So, but yeah, here let's see what we can find in terms of Seyfert galaxies. Two largest groups of active galaxies, along with quasars. They have quasar-like nuclei, very high surface brightness, strong, high ionization emission lines. So yeah, when you look at sort of a normal galaxy, you're just looking at stars. Basically the spectra of sort of the collective light from all the stars. And stars, emit light, and they also absorb light. And I guess in these cases, those emissions are just very, very strong. So these galaxies glow a little bit brighter than your normal galaxy does. 10% of all of them are Seyferts. Powered by the same phenomena that occurs in quasars. Pretty cool. Yeah, and I guess that's why these are relatively new ideas, because we had to be looking at these objects at different wavelengths. They don't, they're not particularly interesting in the visible, right? They just look like a galaxy, right? But when you look at them with the ultraviolet or the X-ray or the radio, anything else, it's like, these hidden structures all of a sudden pop out because you're looking at different stuff, and so yeah, that's what made them pay attention a little bit more. And I guess they're learning that they are active and pretty crazy. Let's see, type 1, type 2, and then it's hard to categorize things, but we do our best. So there's a Seyfert that's also a Messier object, M77. Cool.
What is it that puts them into different categories?
Well, we would have to look. It's just different characteristics, whatever those are. Let's see here. So type 1s are very bright in the ultraviolet and X-ray. Two sets of emission lines, narrow lines and broad lines. Okay, yeah, so here's, I guess, one of the most obvious things is that type 1 Seyferts are brightest in the ultraviolet and X-ray, while type 2 is brightest at the infrared. So that's pretty cool. That's yeah, interesting. Yeah. So, and then, you know, they're finding other little subclasses too. So it's starting to get messy, and you know, we're going to find that you know, everything is pretty unique out there. You know, if you divide things up enough, they're all going to be their own category. And yeah, I think that's sort of what's happening here. So there's another Messier object that's a Seifert. Oh, now I didn't know that one, but I guess Messier 51 and 88 are also Seiferts. Taurus A, didn't know that one either. Wow, so there are quite a few. Wow, okay, so yeah, here's some examples at least. And yeah, there's M51, M66, 77, 81, 88, and 106. Wow.
Fair few, huh?
Yeah, and you know, this is just a very, very short list, right? I think they said what 10% of known galaxies are Seiferts. So there's lots of them. Very cool. Let's see. Let's do 3660 here and see. There's an unabsorbed Seifert 2. Not quite sure what an unabsorbed Seifert 2 is. Okay, well, yeah. So wow, this was all the way back in 1983. Nuclear activity. Let's take a look. Come on, Slowpoke.
Oh.
Here we go. There we go. Good job. So, the Federal Republic of Germany. So, radio observations observed with the 100-meter radio telescope. 5 gigahertz. Okay. Optical and ultraviolet observations made with a 1.5 meter and 3.6 meter spectrograph. Cool.
5 gigahertz makes me want to date where in the Wi-Fi, where in the 5 gigahertz is the Wi-Fi at.
Yeah. Yeah, that's definitely interfering with Wi-Fi, right? I think this is
2.4.
Yeah. I think this is I think that's millijanskis. I think that M stands for milli. So thousandth of a, 11 thousandths of a Jansky. Not quite sure how much power that actually is. X-ray observations done with Einstein. That was the X-ray observatory up there at the time. I think Einstein is gone now. I think Rosat took over where Einstein left, and I think and there's Chandra as well. And I think Chandra's still going. I don't know about Rosat. I think it's gone too. All right, so here's just a, this is 1983, so they have basically photographs still. But I guess this is the X-ray placed over the Palomar Sky Survey plates. So you can sort of see, it's kind of hard to tell that there's a galaxy there, but there is. And then overlaid on top of that is the X-ray emission. And yeah, there's some structure there. It's, pretty low res. That's what they had at the time. And whoop, yep, there's more. It's trying. Okay, so there's an optical spectrum of NGC 3660, our object of the day. Always like to see spectra. They tell us so much about the object. Spectroscopy. I would dare to say, I think this is pretty true, that with spectroscopy you can, everything is there for you just to have. All the info that you could possibly want is in a spectrum, right? If you want to measure how bright this object is, at some wavelength and band pass, you just measure the area under the curve, and that's it. So photometric data can be extracted from spectra. Depending on what these emission lines and absorption lines are, you can determine what this, right? Is this, this doesn't look like, this might be like H alpha. I don't think that's H beta. I think H beta is around here. It's around 4,800 or so. So yeah, identified anything on the chart here, but if we sort of look and see, let's see, the inset shows with better resolution the spectral region around iron 14. So that's iron ionized 13 times. Wow. What is iron? What element number is it? 26, atomic number 26. So that means it has 26 electrons. But so iron 14 means that I think that 12, right? 26 minus, well, it's actually 13 times ionized, right? So there's only going to be, yeah, I guess there's going to be 13 electrons left, right? So the sort of the outer 13 electrons have exited because it's too hot, right? Too energetic, and has left sort of the inner 13 alone. And so, yeah, I think that's what this is showing here at 5303, 51, 52, 53, 5303. Okay. I guess that's probably, oh, that's 54. Well, anyway, they think that they're identifying these lines, and yeah, I mean, I guess. magnesium. I don't know what MGH is. Magnesium hydrox. Wow, I don't know that one. It's some kind of molecule. Magnesium and hydrogen. Don't know that one.
See if I can Google that.
Okay, cool. Magnesium hydroxide, or magnesium, I don't know what you would call that either. Anyway, I guess they're saying that they're identifying that as an absorption thing here. And then I guess this is emission from that iron 14, and there's some calcium 5 as well.
Yeah, it looks like magnesium hydroxide.
Magnesium hydroxide. Cool. Okay.
It looks like that from the hits.
Yeah. Okay. Interesting. And yeah, I wish 5303 is right around here, but yeah, I don't know. I'm not quite sure what I'm seeing there. Anyway, it's nice to see a spectrum. You can see that you know it's brighter in the red part of the spectrum than it is in the blue. You see, it's up to almost to 3, right here. We're down here, it's almost down to 1. So substantially brighter as you move into the red. And you've got these huge emission lines here. As I said, I'm pretty sure this is hydrogen alpha, because I think it's around 6,700 angstroms. I think that's about right. So, all right, well, cool. So that's a nice optical spectrum of our galaxy of the day. What the heck is this? Continuum flux density measurements at ratio optical, ultraviolet, and X-ray wavelengths.
It's Japanese to me.
Yeah, that's pretty foreign to me as well. Continuum flux density.
I thought that was Chinese.
A log of frequency and a log of flux. So this is frequency versus flux. So yeah, I think you know the optical stuff is very high frequency stuff. So I would dare say this is probably the optical. This might be, yeah, you're not quite sure.
Japanese.
Yep. More or less. Okay, so yeah, look, they're even publishing their emission line intensities here. So this is a flux ratio between the measured flux and the flux of hydrogen beta. H beta is at 4861, right, which is what I was trying to point out before. 4861, so 45, 46, 47, 48. So 4861, I don't know. It's in there, probably, hard to tell. I had a chance once, here's just a story, to work with this device called a spectrophotometer. And what you could do with this device is you could dial in any wavelength of light you want. And so just because I dialed in the wavelength for hydrogen beta, right? Which, you know, this is saying it's 4861. I've heard it's 4868. So there's a little bit of variation there. But I gotta say that is probably my favorite color of all time. It's like a bluish violet. It's really, really, really amazing.
Could you show that color on screen by typing in, I don't know, some parameter on Google or?
Yeah, as far as I know, there's no way to really be able to represent that with like RGB. It's really, really hard, to reproduce exactly, those kinds of colors. Exactly.
And then it would be different on all our screens anyway, so.
It would look slightly different on everybody's screen anyway.
Pardon me.
But I think you can actually do that. So let's just hydrogen beta. Yeah, it's part of the Balmer series, the hydrogen Balmer series. Let's see, images. I don't know if it's going to come up with anything or not. Well, yeah, that really doesn't do it too much justice. But that's kind of close, I guess. And as you say, I mean, it's going to look different on
4861 caliber spectrum. What do you mean by 4861?
What I mean by that is that is the wavelength.
Check the chat. Check.
Oh, check the chat. I gotta check the chat.
Is 4861 a baseline then, or?
Well, what they can do here, right, is they can choose any reference line they want. They just, that is sort of an arbitrary choice. H beta is sort of a known thing, right? So it's just wise, to choose something like that, that apparently, they have moderately good signal on, so they can use it as a reference, right? And so what this is saying.
Nice catch, Bobby.
Right? I want to see. Oh, but he is extremely welcome here.
He'd probably be watching Fox News.
Anyway, so what this is showing, right, is that these emission lines, these oxygen 3 lines, are at times, 3 times brighter than like the hydrogen beta, right? So pretty amazing. 8.8 times brighter with the hydrogen alpha. Pretty cool. Let's see what else we got here. That looks like about it for that.
Anybody thinks that any news is fake news, they're fake news.
Well, you just have to be very, very, very discerning. Because, gotta say that so-called fake news has been around for thousands of years. So nothing new there. We just have to be nice and discerning. That's pretty easy to do.
And I read a comment one time on one of Justin's shortwave videos, and I think he said the truth. It's better to hear the good news on the radio than the fake news on the internet.
Well, I suppose so. Yeah, I think that's about right. All right. Well, with that, I think I'm gonna get on out of here. As I said, I've got to decide. I did not mean for that to be up.
Go for it, mate. Go for it.
Yeah. Look, we'll see. We'll see how things go. I've got to keep my eye on the sky. So it's always a contention. So we'll see how that goes. And yeah, if it looks like it's going to be clearing up in the next hour or so, I'll probably go for it. So who knows?
Oh, before you go, Matt, I discovered what unabsorbed is.
What is?
Unabsorbed. I've still got some here in the can.
Ah, that explains it.
It will soon be absorbed.
By definition, yes. All right, everybody. Well, I think I'm going to get out of here for now. So have a great evening, a great day, wherever you are. Thanks for coming in again. I will be here again tomorrow, same time, same place, 2 hours UTC. Just shooting the breeze with some astronomical talk and some nerdy things, whatever it is.
Cool.
Yeah. Just it's just a lot of fun. I like being able to talk about this thing that I'm just intensely passionate about, and it's just a lot of fun. So, all right, buddy, I'm gonna get out of here for now. Peace, cheers, and all that. I will see you in a little less than one of these Earth spins. All right, take care. Live long and prosper.
Live long and prosper.